Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. We're going to start today with a simple question. How difficult is it to tighten a fastener? Whether it's a screw, a bolt, or a nut, how difficult is it? What's involved? Seems like a simple enough question. At least it is until you begin to ask some important questions about the task. Are there life safety issues at stake? Are there quality control requirements? Do you need to capture any data about the task? How much time is allotted for the task? Does the process need to be automated or can it be performed manually? Once you begin qualifying exactly what needs to be done, the simple sounding task of tightening mushrooms into something much more complex and significant. And with the advance of technology, always progressing, always changing, the question of how difficult it is to tighten becomes a difficult question itself. Because the new capabilities brought by continuing advancements in technology allows for much more to be accomplished while fulfilling the simple task of turning a fastener to make it tight. What else can be accomplished during the process of tightening? How can the process be integrated into a modern-day manufacturing environment? Can a manual tightening process still achieve the repeatability and the precise results required by ISO-mandated procedures? To help us work through these questions and the technology is Mr. Jim Ross, Product Manager at Morrell. Jim, thank you for joining us.
Thank you for having me.
Well, let's start out. I introduced you, but tell us a little about yourself. How long have you been with Morrell? How long have you been in the industry?
I've been with Morrell now for 4 years. I'm the tightening product manager for the tightening systems at Morrell. I've been in the industry for about 25 years with Rexroth, originally the manufacturer of the tightening tools that we're talking about. So I have an extensive amount of experience.
All right. Well, let's start simple. Let's just talk about what are the concepts involved in tightening. I think everybody, all of our listeners have probably put a screwdriver on a screw and tightened it, or put a wrench on a nut and tightened it down. What are the concepts involved besides just turning?
Well, nowadays things have changed quite a bit from the previous, just putting a screwdriver or a wrench on something and tightening it. The concepts now are you need to understand the joint that you're actually building. The joint is the amount of clamping pressure, is the end result from any torque tightening application that we do nowadays.
They talk about how much torque it takes. I've used air tools before, and really the specification was tighten it down, and I'd run it down until it would stop moving. Why is that wrong, bad, or different?
Well, at the time it wasn't wrong, but they had big bolts, big nuts, and what they would do is they would oversize everything because they didn't know what they were getting out of the end. They just wanted to hold things together. Nowadays, what they've done with these new torque tools is they find that they can test it and they can get feedback instantaneously on what they're getting for torque and angle or rotations, and find out exactly what the clamping pressure is through all the feedback from these systems.
So I get the feeling that you're saying that they've reduced the size of the fasteners.
They absolutely have.
Is cost savings. The fastener now is less expensive because there's less material in it.
That's correct. They made them smaller, lightweight now, and out of different alloys and plastic. Before, we never put plastic screws into anything. It was always a steel screw. Now, since they can make those fasteners smaller and understand the clamping pressure, they can make everything smaller and lighter and assemble faster, which saves you time, cost, and money.
So, torque. How much torque do you put in it? Are there other characteristics or other variables that we need to be concerned about?
Absolutely. There's the rotation, how many rotations that it is.
How much you turn it.
Exactly how it goes down. And then you have a pre-torque and a final torque. And if you wanted to, you could condition the joint as well, where you could tighten it, loosen it, and then retighten it. And in some applications, that happens.
Why would they do that?
That's what they call conditioning the joint. They bring things together and then they let them relax, and then they clamp them again to get everything aligned properly.
And that makes for in certain cases, that makes for a better joint, is what you're saying.
That's correct. In some manufacturing facilities, that's required.
Okay. And so they're measuring the torque, and now you said something about the rotation. So they're
Yes.
doing a distance or counting the number of revolutions that it goes around?
That's correct. On the way down, when you're tightening a bolt, it has to go a certain amount of revolutions, say 10 revolutions. And in that 10 revolutions, you don't want to see any binding on the threads. If you're monitoring the revolutions and the torque at the same time, you can actually see if there's thread interference before it gets to the final torque.
If they know that it needs to go 10 revolutions, but at 6 revolutions it hits the torque target, something's wrong.
That's correct. And with the new tools nowadays, it will reject it.
So that implies a level of intelligence or automation, knowledge, or control that certainly doesn't exist in an open-ended wrench, a box-style open-ended wrench or a screwdriver.
It doesn't. That's correct. In the old days, like I said, you just run it till it's tightened all the way down. And now you can monitor each one of those steps. And you can have several steps in every rundown. And in fact, the more steps that you put in a rundown, the higher the quality of the joint that you're tightening.
Okay. That's the concepts involved in tightening. On the screen here beside us, we actually have a couple of pictures. Are these tightening tools? Tell us what they are and what's the difference between them.
Well, on the left-hand side, we have what we call the Rexroth Opex wrench. It is a digital manual torque wrench. The difference between this is
Somebody pulls on it.
somebody pulls out, that's correct. And the difference between this one and the older ones is the older ones were analog where there was a needle on it.
There's a needle.
Yeah.
Yep.
The new ones now, it actually, you pull it and then the transducer in the end of this will actually give feedback to the device and vibrate the handle and turn the lights green when you get into the correct torque.
It doesn't stop you from turning it. It just tells you to stop turning
That's correct.
or stop pulling.
Right.
So you said a sensor. What is that sensor measuring?
There's a transducer in that measures the angle of rotation as well as the torque. And it also measures the direction that you're going, if you want to go clockwise or counterclockwise.
So the torque and the rotation, it's measuring both of those
Simultaneously.
simultaneously. And it feeds it into the control that's, I'm guessing, in the handle here?
It is. And with that control system that they have in the handle that's built in, you can actually send out all of that information Wi-Fi to the FTP server. So all of the
Interesting.
data that you collect, you can send that out and collect it for quality analysis later on.
But this is a manual, and the sensor actually doesn't prevent you from doing any further tight. You could over torque it still if you wanted.
You could, but that's where the programming comes in. If you over torque it, it will now, instead of the lights turning green on there, they will turn red.
Okay.
And it will reject it. And that data is also saved. So then it will allow you to rework.
Okay. What's the other tool that you've
The
got
other
there?
is the Nexo 2 tool.
Is that a manual tool also?
That is a manual tool, but it has a servo drive in it. So instead of just the last little bit of torque, this can run down for angle as well. But since it's a servo drive, it's going to continuously rotate and you don't have to move it around the bolt.
So because it's a servo, because there's the sensor in it, does that mean it's closed loop control?
That is. It is a closed loop system.
With the tool on the right-hand side of the screen, can you over torque something?
No, when that gets to torque, it shuts off. You can't over torque it. And if you're going too fast and overspeed it,
Overspeed?
right, then it'll do the same thing as the OPEC wrench. You'll have a program with the parameters in there. You have limits on each side, and it says, I'm within the specifications you've asked for, or it will reject it.
But there's still a trigger on this, and this is still some person is holding that in their hands and pulling the trigger.
Right.
So both tools are manual. One is manual power,
Yes.
and the other is just holding it and letting the servo in there do
All the work.
all the work and closed loop.
Yes.
What about fully automated, where there's no person involved in putting the tightening tool onto the fastener to be tightened? You have those, I'm sure.
Absolutely. Rexroth has a total line of what we call fixture tools. It's a standard tool that you mount in a machine. There's no human intervention in this whatsoever.
Same technology that's in
Same
these?
technology.
Servo motors and
Exactly.
gearboxes?
Yes, the motor, the gearbox, Then there's the transducer and the different outputs that are available for that. And there's a wide range of stuff that meets all of the industry needs. So what happens is they mount the tools in there, and if they wanted to mount 10, 15, 20, or 40, it doesn't matter.
Really?
They can run them all simultaneously and synchronize them all.
So like all of the bolts in a head in an automobile, or
Yes.
or 5 or 6 bolts on a lug nuts on a tire.
That's correct. Both of those applications and many, many more are all done with the fixture tools.
And a person is involved, but he's not actually holding the tool as they would be in either of these two.
Usually in these type of automatic situations, the torque is much higher, so there is nobody holding anything. It goes through on a production line, say an automotive engine production line, and it may go through 15 or 20 stations with these automatic tools. 5 in one station, 10 in another. So,
on those fixture tooling, are you still getting the same kind? Where does the data? How does the data get out of the tool?
in that case, what happens is the data is conveyed to the controller, the Bosch Rexroth controller, and then from there you can either send it out via FTP or back to your PLC to do manipulation with it, whatever you like.
So they can send it to the network and put it into a factory information system,
Exactly.
as an example.
Right. They can also scan the VIN number of the engine that they're using and store that as well for that traceability.
So why would they want to do that?
When they go back and take a look at the performance of any of the engines, they can go back and see which one was
By VIN number.
By VIN number. They just search that and they can get all of the data for every bolt and nut that's been assembled.
Date, time, how much torque, how long did it take,
Exactly.
all of that information.
Exactly.
The technology has been around for a while, I'm guessing. How long have these been around? Is this new technology or?
The technology has been around quite a while. It has improved over the years. They've gone from analog to digital. These are all digital transducers we're looking at here. Analog is a little bit less accurate than these. These are very accurate because the decision is made at the transducer rather than at the control. On the analog stuff, it has to send a signal back to the controller, and then the controller makes a decision on the torque.
These are programmable
They are.
through a computer, is that?
With the Nexo 2, it's an onboard
That's
software.
the one on the right.
On the right. It's an onboard software program, so all you need is a browser and the IP address and a password, and you can go ahead and get in there and take a look at the entire profile that you've programmed, or the torque, the final torque, or even the graph. It can be done with any smartphone. On the fixture tools, you have a software program that's loaded on your laptop, and you hook up to the controller, and you can get all of the data out or manipulate any of the data that you like.
How do you see the change of technology or our advancing technology? How do you see those impacting these tightening tools? What does the next 5 years look like?
In the next 5 years, looks like the actual footprint of all of these tools will be smaller and smaller. The electronics have gotten
Gets
better.
more powerful, the motors get more powerful.
Exactly. With the rare earth magnets on the motors and some of the electronics getting smaller and smaller, we're expecting some of this stuff to be reduced by half the size.
Half the size?
Yes.
Okay. Do you see changes in the number of applications that these are going to be involved in?
Absolutely. We're seeing more and more where everybody is going from that manual air wrench or that manual torque wrench to a DC nut rudder like these. Just because they need to look at the data that's coming out of it, they need to track it. There's a lot of tracking and traceability when it comes to this stuff now. If you're putting lug nuts on a car, you do not want one of those to come off because it's a safety and function critical application.
Life safety.
Exactly. We're talking life safety. You don't want things falling off in midair or
maybe an airplane door.
Exactly. At this point, when you were using one of these tools, you would have recorded each one of those. They'd send it to a database. That database could have checked to make sure that it was tight. Without any human intervention except for pulling the trigger. There needs to be no knowledge base by the operator to do that. He just needs to follow a pattern. And then that would go with the build sheet of the plane or the car.
So greater adoption in the future is not being driven necessarily by technological advancements. You're saying that it's going to be driven in large part because people want more information.
Correct.
And if I've got a guy with a manual torque wrench that's analog with the needle, I get no data from that.
Absolutely none. It's their best guess, and it's nowhere near as accurate as they need on these vehicles anymore.
That's fascinating. Jim, ran out of time. Went quickly. Thank you so much for taking the time. Maybe we need to revisit this.
I appreciate the opportunity.
All right.
Thank you.
Jim, thanks for joining us. To learn more about Morel and their systems and solutions, visit morel-group.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.